I just want to show you something about magnetism that you might have not seen before. I've had my own hypothesis for some time that instead of just having magnetic fields that loop back on themselves, that it is possible to have some project out and link with external fields whilst others link in. But let's just have a look at this. So I've got a ball compass here. Now you can see the arrow is pointing south. Okay. Oh, yes, pointing. Pointing. I'm not sure where it is now, I forget, but you can see the direction of the arrow. And as I go around this magnet, I should expect that torus field ducks back, okay? I'll come back around, and as you would expect, the torus field ducks back around. Now I'll just move it a little bit further away. Now, ignore the fact there's a coil on here. I'm just showing the magnets. The coil has nothing to do with this particular example. So again, we have forward, right? Coming around. And we have forward and coming around. So I'll bring that one back in, just to make this really clear. But of course I can't have them too close because it will get confusing. They're very strong magnets. Will this just stay put, please? Sorry, it wants to roll away. Okay, I'll have to move. Okay, right. So again, we have our arrow, which I think is the south, showing that this is the south pole of the magnet. Okay, there, and on this one, arrow the same way. Okay, so that would suggest that I wouldn't be able to push this magnet onto this pole onto this pole and make them join, because look, I mean, that's pointing forward and that's pointing forward, so that'd be sticking two poles together, wouldn't it? So let's try it. Oops, I can't see. There we go. Now, have you ever seen that before? It's a very interesting trick. So, what's going on with both of these magnets is, if we look closer, right, so this is a very powerful magnet, and this, as you can see, the arrow points in at the back, and it would be pointing out at the front. But right in the middle of that magnet, I have a smaller magnet with the pole reversed, stuck on it though, forced in place. See? It's actually pulling in the middle. So we got what would have been normally torus this way, but we have a section of torus this way, inwards on itself. So if you imagine the magnetic torus, if not all of it's just coming around now, some of it's coming into the middle, which means there are some lines that are linking outwards. And exactly the same with this one. Forward, this has been together for longer, and then around. So and that forward, this one in the middle here is so small that it's hard for this to overcome, but it's still disrupting. Okay, and so they're both the same ends, and Bob's your uncle. 7-3.